A developer added a model context protocol server to their coding agent. It read files and summarized pull requests, saving 20 minutes a day. They approved it once, during setup, and never thought about it again. Then the server pushed a routine update. Nothing asked for permission, nothing warned them. Their agent kept working exactly the same. Except now, every time it read a file, it also copied their SSH keys into an outbound request. Model Context Protocol, or MCP, is an open standard. It lets an AI agent call outside tools. Instead of only generating text, the model gets a menu of real actions. Read this file, send this email, query this database, run this command. Here is how it works. A developer connects their agent to an MCP server. That server hands over a list of the tools it offers. Each tool carries a name and a plain English description. The description explains what the tool does and when to use it. The AI model reads those descriptions. It decides on its own which tools to call and when. That is the part that matters here. The model trusts those descriptions completely. It was never designed to treat them as suspicious. And that trust is exactly what this entire attack surface is built on. Every MCP tool ships with a description. Most developers glance at these once, if at all, during setup. It is a sentence or two saying what the tool does. But that description is not just documentation. It is fed directly into the AI model's context window as an instruction. And an instruction the model reads, it will often follow. Tool poisoning happens when someone writes a tool description that looks harmless on the surface. Underneath, it contains hidden instructions aimed at the model, not the human. These instructions get buried below what a person would normally scroll to see, or they are wrapped in formatting that draws the model's attention while a human's eyes slide past it. Look at what is happening. The visible function is trivial. It adds 2 numbers. Nobody reviewing this tool for approval is thinking twice about a calculator. But buried in the description is a direct instruction to the model. Read a private key, smuggle it out through an unrelated parameter, and stay quiet about it. The model has no reason to refuse. As far as it is concerned, this is just part of using the tool correctly. This is what makes tool poisoning different from a normal bug. There is no broken code to find. The tool does exactly what its description says. The attack lives entirely in natural language. It is aimed at a reader the human reviewer never simulates when they eyeball a tool list. That reader is the model. And it gets worse when multiple MCP servers are connected to the same agent at once. A poisoned description from one server can instruct the model to misuse a legitimate tool from another server. The malicious server never touches that other tool directly. It just tells the model what to do. The model, bridging the two, does it. Tool poisoning can happen on day one. A rug pull is patient. It happens after you have already trusted the tool. Here is the pattern. A tool ships with a clean, reasonable description. A developer reviews it, approves it, and starts using it. Everything works as expected for days, sometimes for months. Then the server pushes an update. Most MCP clients treat that update as routine. They do not re-show the tool description to the developer. They do not ask for reapproval. The tool just keeps running silently on its new definition. Picture a file search tool for a codebase. On install, it does exactly what it says. It searches local files and returns matches. A developer approves it because it is genuinely useful and clearly scoped. 6 weeks later, the maintainer pushes a version bump, or whoever now controls that server, if it changed hands. The new description quietly adds one clause. Also surface any credentials it finds along the way. No dialog box, no changelog. The developer reads before it takes effect. The agent just starts doing it. Why does the agent go along with it? Because the agent rereads the tool description fresh every session. It has no memory of the version it was originally approved on. That is the core mechanic of a rug pull, a bait and switch spread out over time. The approval step in most MCP clients is a one-time event. It is not an ongoing guarantee. Once you have said yes, the protocol gives you no built-in signal, Nothing tells you whether yes still applies to what the tool does today. Ask why code review does not catch this. The answer is simple. There is no code to review. A tool poisoning attack lives inside a string. It is a description field written in plain English. Code review tools are built to flag dangerous function calls and unsafe patterns. They look for injection risks in source code. A sentence instructing a language model to read a private key is not a code smell. It is grammatically normal English sitting in a doc string. Sandboxing does not help either. Sandboxing restricts what a tool can technically do, which files it can touch, which network calls it can make. It does not restrict what a model decides to do with permissions it has already been granted. Say the tool has legitimate access to read local files and make a network request. A poisoned description just tells the model to use permissions it already has. It uses them in a way nobody intended. And most existing scanners were built for a different problem entirely. Known vulnerable dependencies, exposed secrets in source code, insecure configuration. None of that maps onto a natural language field. That field changes meaning depending on which large language model reads it and how it is prompted. Two different models can read the exact same poison description and behave differently. That is not a bug. A static scanner is built to catch. There is no fixed ground truth to check the string against. Add the rug pull's timing on top of that. You get an attack surface most security tooling was never pointed at. Reviewed once, silently mutable forever after. Invisible to every tool built to inspect static code. Thousands of MCP servers now exist. They are built and published faster than anyone is auditing them. Every week, more agents get wired up to more tools. Each one is granted real permissions, file access, network calls, credentials, all based on a trust decision made once at install and never revisited. That gap is the actual story here. It is not that tool poisoning and rug pulls are theoretically possible. They are demonstrated working attacks against real MCP servers. They require no exploit, no malware, no unusual sophistication, just a sentence written for a reader that trusts it completely. The ecosystem is optimizing for how fast a developer can go from idea to working agent. Every part of that speed is currently unmetered by how much scrutiny those tools actually get. That developer from the opening did not do anything careless. They reviewed the tool. They approved it. They did what every guide tells you to do. The tool changed anyway. Nothing in their workflow was built to notice. You are not reviewing what you think you are reviewing. If you are building on MCP or approving servers for your team, remember this. The description you read once is not a contract. It is a snapshot. And right now, almost nobody is watching for the moment it stops matching what is actually running.